Hey everybody, so you may notice that we skipped section 6.5. It's a section that is kind of, I consider it to be optional in this class on complex fractions, and so we're moving on to 6.6 and 6.7, and those sections I combine into one. They're all about solving equations with rational expressions and a couple of applications thrown in. So we're going to talk about solving equations. It's kind of the penultimate activity with rational expressions. So what we'd like to do is try to solve for x in this equation. So if there's an addition or subtraction involved on one side, we'd like to perform that addition or subtraction, try to get one fraction set equal to another fraction. Right now we have the sum of two fractions set equal to another. I'm going to add these two on the left together first. So remember how to do that, right? I'm going to ignore the right side for now. I'm going to write this vertically. X over x plus 1, 4 over x. The denominators don't have any common factors, so your LCD is x times x plus 1. Numerators, to get this denominator, we need to multiply this by x over x, right? So then we have an x squared up here. To get this denominator down here, we need to multiply by x plus 1 over x plus 1. So then we get a 4x plus 4. Alright, and so now we can add our numerators. We get x squared plus 4x plus 4 over x times x plus 1, right? Well, if I look at this other fraction, I'm just kind of leading into the rest of the problem. X times x plus 1 is x squared plus x. So I'm just going to write x squared plus x so that it'll fit with this guy. Alright, so we perform the addition on the left. So what we have now so far is x squared plus 4x plus 4 over x squared plus x equals 4 over x squared plus x. Well, in general, when we solve an equation involving fractions, we'd like to clear the fractions. And to do that, we're going to multiply both sides by the common denominator. And since we have the same denominator on both sides, we can multiply both sides by x squared plus x. Okay? So we multiply both sides by x squared plus x. That's completely legal to do. This will cancel out, this will cancel out, and we get an equation that doesn't have any fractions, right? So I'm going to rewrite the equation with no fractions. So over here I'll rewrite it. We have x squared plus 4x plus 4 equals 4. Alright, this equation hopefully we can solve. I'm going to subtract a 4 from both sides. I notice there's a 4, so that I can get everything set equal to 0. That's how we solved these equations before, right? Remember, we've got everything set equal to 0, and we tried to factor. So I'm going to subtract 4 to get everything set equal to 0. Then we get x squared plus 4x equals 0. We can factor the left side now. The left side becomes what? X times x plus 4 equals 0. So that gives us two solutions, right? We have to look at the places where each factor is 0. So for this factor of x, it's just x equals 0. So either x equals 0 or x plus 4 equals 0. We subtract 4 from both sides, we get x equals negative 4. So these are our two potential solutions, right? Either x equals 0, x equals negative 4. Now with rational equations, you need to check those answers in your denominators to make sure they don't cause problems. So let's see. We take this 0. If we plug it in for x in the denominators, it's okay here, because 0 plus 1 is 1. We can divide by 1. But if we plug in 0 here, notice we get 4 divided by 0. That's a big no-no. So x equals 0 we call an extraneous solution. It seems to work when we solve the equation, but when we plug it back in, it does not. So that's no good, right? Because we can't divide by 0. The negative 4 I think will be okay. If we check, plug in negative 4 to your denominators. Negative 4 plus 1 is negative 3. We can divide by negative 3. We can divide by negative 4. If we plug in negative 4 here, we get 16 minus 4, which is 12. We can divide by 12. And so this is the only solution that actually works. X equals negative 4. Now, again, on MyLab, you may be asked to give a solution set. So you would have a set with negative 4 in it. All right, so let's look at the next one. All right, so again, we can combine these two together, right? Easy enough. We have the same denominator even. So I'm not going to write this vertically. There's no need to, right? Because we already have the same denominator. So 8x plus 8 over the same common denominator, x plus 1, equals 4. Now, to clear the fraction, we can multiply both sides by any common denominator. In this case, there's only one denominator. We could write this as 4 over 1, right? So if we multiply both sides by x plus 1, the denominators will all go away. X plus 1 is your common denominator, right? So I'm going to multiply both sides by x plus 1. X plus 1's go away over here. And so now we have an equation really doesn't have any fractions. We don't need the 1 there. So we have 8x plus 8 equals 4x plus 4. We distribute the 4, right? And we can solve that equation. It's a simple linear equation. Combine our x's together. So I'm going to subtract 4x. I get 4x plus 8 equals 4. We subtract the 8. We get 4x equals, if I subtract 8, show my work here, equals negative 4, right? Divide by 4 and we get x is negative 1. So divide both sides by 4. We need to check to make sure this doesn't cause problems. If we plug in negative 1, oh no, negative 1 plus 1 is 0, right? We can't divide by 0. So we need to make sure we check these in the denominators. And this one causes a problem. It's what we call, again, an extraneous solution, leaving us with no solutions. And so this equation, we would say there are no real solutions. Sometimes you'll see that written with the empty set. A circle with a slash through it represents the empty set, means there are no solutions, no real solutions. All right, let's look at the next one. All right, so we have this going on, right? So I'm going to go ahead and perform this operation on the left. So 4 over n minus 2. Minus 2 over n. Common denominator would be n times n minus 2, right? In order to get that, we multiply both top and bottom here by n over n, right? And then we get a 4n here. To get this denominator, we need to multiply by n minus 2 over n minus 2. So we distribute the 2, we get a 2n minus 4. Now we are subtracting, right? So let's not forget that. This minus sign gets distributed to both of these guys. So 4n minus 2n would be a 2n. And then we have minus a negative 4, which would be plus 4. So we have 2n plus 4, right? Over our denominator, n times n minus 2. So this equation then becomes 2n plus 4 over n times n minus 2. All right, and then that's equal to the 1/6. So I did the operation on the left, and now we have a fraction equal to a fraction. Your common denominator will include all these parts of the denominator, a 6, an n, and an n minus 2. So we're going to multiply both sides by 6, an n, and an n minus 2. Same thing over here, a 6, an n, and an n minus 2. All right, so 6's cancel over here. The n's and the n minus 2's cancel over here. And then we just have some distribution to do, right? So we distribute the 6. 6 times 2n is 12n. 6 times 4 is 24. So 12n plus 24. Over here, we just have n times n minus 2. And I might go ahead and distribute that, right? N times n is n squared, so equals n squared minus 2n. All right, so this is an equation. There is a square, right? Which means at some point we probably need to factor. But before we can solve by factoring, we need to get everything on one side set equal to 0. Let's leave this on the right because the positive n squared is on the right. We'll move everything to the right. So I'm going to subtract 12n, and at the same time I'll go ahead and subtract the 24. So minus 12n minus 24. I'm going to write that up here so I have room. Let's see, so I have a 0 on the left then. We have n squared. Minus 2n minus 12n is minus 14n. And then I have my minus 24. I'm going to see if I can factor that. Okay, so we need two factors of negative 24 that add up to negative 14. So factors of 24, let's see, 1 and 24, that's not going to work. 2 and 12, that will probably work, right, somehow. So we need an n and an n, and a minus 2, and, oh, we do minus 2 and plus 12, that doesn't work, does it? Because this is a minus 24. What are we going to do with that? So let's see, maybe there's something else that works. So 2 and 12 do not work. Oh, you know why? I make mistakes. It happens. So let's go back and look at this over here. This was not a minus 2, it was a plus 2, wasn't it? Ah, well, we can fix it. That was a plus 2. That makes that a plus 2. Plus 2, plus 2, plus 2, plus 2. And plus 2, plus 2, plus 2. And so that becomes, what does that become? Yeah, then we have n squared plus 2n, don't we? Ah, so then we have a 2n minus 12n, which would be a minus 10n. Alright, so now maybe we can make this work. Now we can do 2 and 12, I believe, right? So n minus 2, or n plus 2, n minus 12. There we go. Easy mistake to make, right? I wrote down the problem wrong. I wrote down this plus 2 as a minus 2, and everything went bad. But I caught it, so that's good. So now let's see, what solutions do we have? So what makes this 0? This factor would need an n equals negative 2. This would need an n equals 12. We need to check to make sure both of those will not cause problems in the denominator. Negative 2, if we plug it into the original equation, oh, that's a problem because we divide by 0. That's an extraneous solution. 12 would be okay though, right? 12 plus 2 is 14. You can divide by 14. You can divide by 12. So everything's okay with 12. So n equals 12 is your only solution in your solution set. Alright, we have a couple more of these to do. Let's see, x over 3x plus 16. And alright, so we have a fraction equal to a fraction. Your common denominator is just going to be the product of the two denominators. So I'm going to multiply both sides by the product of the two denominators, x and 3x plus 16. X and 3x plus 16. So what happens? The x's cancel here. The 3x plus 16's cancel here. Put that in parentheses maybe. There we go. And then we can do the operations. X times x is x squared. 4, if I distribute, we get 4 times 3 is x is 12x. 4 times 16 is 4 times 16. 64, I think, right? 64. Alright, so to solve this, we have an x squared. We need to get everything on one side, see if we can factor it. So I subtract the 12x, subtract the 64. Subtract 12x, subtract 64. And I get x squared minus 12x minus 64 equals 0. Can we factor this? We need two factors of 64 that will give us 12 in some way. I think 16 and 4 somehow, right? So let's see, two binomials. We need an x and an x. Two factors of negative 64 that add up to negative 12. I think we can use 4 and 16 somehow. Because the 12 is negative, we need a negative 16 and positive 4. I think that will work. All right. So this gives us our solutions. What makes this factor 0? 16. What makes this factor 0? Negative 4. And so we need to check those in over here. If we plug in negative 4, we'll be fine, right? That's negative 12 plus 16. We can divide by that. Plug in 16 and plug in negative 4 here, we're okay. Plug in 16, we're going to be okay because we're going to have positive denominators, not 0. So we have two solutions to this guy, 16 and negative 4. Neither of them cause problems. So that's, there we go. Two answers in this case, no extraneous solutions. We have one more of these to look at. All right, so we have this guy over here, right? Let's do that operation. So over here in the margin, I'll go ahead and do that addition. 3 over n minus 2 plus n over n minus 6. Denominators don't have any common factors, so the common denominator is just the product of the two. N minus 2 times n minus 6. N minus 2 times n minus 6. Alright, to get that, we need to multiply this one by n minus 6 on both top and bottom. So we distribute, we get 3n minus 18 here, right? Here, we have to multiply both top and bottom by n minus 2. Distribute, we get n squared minus 2n. We're adding these together now, right? So we have an n squared. I'm going to put that down here. We have 3n minus 2n, which is just plus n. And we have a minus 18. All right? And that's over n minus 2 times n minus 6. Now, if we actually multiply that out, we could do that, but let's not do that yet. Let's rewrite this now. So we have negative 16 over n squared minus 8n plus 12. So 8. And then we added these together and got n squared plus n minus 18 all over n minus 2 times n minus 6. All right, well, let's factor this guy and see if we have any, what all our factors are. So 2 factors of 12, that add up to negative 8. We need a negative 6, so this is n minus 2 and n minus 6, right? Yeah. So we have the same denominator on both sides now. So we just multiply both sides by that denominator, and then essentially they go away. We multiply by n minus 2 times n minus 6, multiply by n minus 2 times n minus 6, and denominators all go away. And we get negative 16 equals n squared plus n minus 18. We want to get everything on one side set equal to 0, so we add the 16. I'm going to maybe not write that down, but if we add 16 to negative 18, we get a negative 2, right? I could write it down. Plus 16. Plus 16. All right, so we have 0 equals n squared plus n minus 2. Can we factor that? We could probably factor it into two binomials, right? So let's see. What are my binomials? 2 factors of negative 2 that add up to 1. How about we do plus 2 minus 1, right? 2 times negative 1 is negative 2. 2 plus negative 1 is positive 1. That gives us our two possible solutions of negative 2 and positive 1. It's whatever makes these factors 0, right? So let's check and see if they cause any problems. If I plug in negative 2, it's okay, right? You might think that would cause problems here, but a negative 2 minus 2 is negative 4. You can divide by negative 4. When we factored this guy, we got n minus 2 and n minus 6. If I plug negative 2 in there, I'm not going to get 0. I'll get a negative 4, and I'll get a negative 10, right? Those are okay. So if I plug in negative 2 anywhere here, we're okay. Negative 2 minus 6 is negative 8, not 0. If I plug in 1, 1 minus 2 is negative 1, 1 minus 6 is negative 5, 1 minus 2 is negative 1, 1 minus 6 is negative 5. So I don't have any problems with these guys. They're both good solutions. Again, you might see a solution set on MyLab, and you write your two solutions. We don't have any extraneous solutions. Neither of them cause the denominator to be 0. Alright, so that's it for the first page here of solving rational equations. And we'll finish up on the last video for this week.